Hi everyone, I'm Lorenzo from Soundmachines, and today we'll see another module from the Eurotouch series lineup, the T-Generator. T-Generator is a multi-parameter through-zero FM VCO. It has three independent outputs, a triangle oscillator, a square oscillator with morphing capabilities, and a pure sine oscillator with a wavefolder. The Eurotouch series differs from other modules with their ability to self-modulate themselves, using the touchstrip, inherited from our most successful module, the LS1 lightstrip. The slider allows us to record automations up to 20 seconds long, giving us the ability to create long evolving sequences or short events. The touchstrips control 4 different parameters, some of which can also be shared with a dedicated CV input or the knob. We can dial in values depending on the position, from lower to higher values, going from bottom to top. The top button is used to select between the hold mode or the loop or one-shot playback modes. The lower button is used to switch between the 4 sliders, with a dedicated LED indicating which parameter is currently controlled by the slider. The reset input is used to trigger or reset the playback of the automations. Now, let's hear something and see how it works. I already patched the 3 outputs from the oscillators to the 3 inputs of the mixer. Let's start by hearing the triangle output, and let's do a simple pitch sweep using the coarse and fine knobs. This oscillator does not have dedicated controls like the square or sine ones, but it's a nice way to introduce the way the sliders on the Eurotouch module works. Whenever we touch the strip, we will generate a voltage that controls the current parameter, in this case, the vibrato. We can see which parameter we are currently controlling by looking at the relative LED in the button below the slider. The vibrato parameters allows to introduce pitch variations from subtle to sample and hold style random pitches. Sliding from bottom to top gradually morphs these types of pitch variations and applies them directly to the pitch information received from the CV input or, like in this case, the base pitch set by the coarse and fine knob. The normal behavior of the slider is to maintain the value until we are not touching it anymore, returning to 0. If we press the record button on top, we can also hold a value. When the hold mode is active, the red LED will stay lit. Let's now switch to the square with morph output. This oscillator has control over the morph function via the slider, and for the PWM over both the slider and the dedicated knob. To control the morph parameter via the slider, we have to press the lower button once. As we can see, now the corresponding LED is lit. If we want to access any other parameter, simply press repeatedly the touch button to cycle through all 4. The morph is used to add harmonic content to the square oscillator. Starting from the bottom and going to the top, we'll start hearing a detuned square oscillator gradually added in. From the last third of the slider total travel to the top, another square oscillator pitched an octave lower is added, summed with a little hint of the sine wave. This is intentional because it is a way to add a bit more character to the sound. The PWM control changes the duty cycle of the square wave. We can control both with the knob and the slider. Let's now switch to the sine wave oscillator. Actually, right now we cannot hear anything because we can think of the fold parameter like a gain knob in the first third of the travel, and then it will control the wavefolding amount. This allows to use the fold as a pseudo VCA. In fact, if we use an LFO or an envelope to control the fold via the CV input, we can control only the volume of the sine oscillator if we attenuate the CV, or control the overall folding if we allow the CV to go into the wavefolding range. We can also control the fold via the slider. In fact, on the T-generator, the fold and the PWM parameters can be controlled via the slider, the knob and the CV input. The module will do a mathematical sum of all the values. For example, if we touch in the middle of the strip and hold a fold value and we start moving the knob, we will hear that at some point the knob will stop having any effect on the fold parameter, because we exceeded the internal maximum value. If we now apply a negative voltage LFO into the fold CV input, it will be summed, and the total voltage will come back to a range where we can hear something. If both the slider and the knob are all the way down, any negative voltage applied to the CV input will not have any effect. If we want to get rid of any external CV sources, we can finally showcase the star of the show, the slider. In fact, we can record automation to act like LFOs, long or short, or envelopes. To start recording, we must put our fingers on the slider first. This will be our automation starting point. Then, once we keep our finger pressed on the record button on top, it will start blinking. To start recording, we must put our finger on the slider first. This will be our automation starting point. Then, once we keep our finger pressed on the record button on top, it will start blinking. When we lift our finger from the recording button, the automation will start looping. If we apply a gate signal to the reset input, for example, in this case from the button output on the modular 114, this automation will reset and start from the beginning. An automation can also be set to one-shot mode. For example, in this case, it can replace the envelope we used before. To set an automation to be one-shot, keep pressed the record button for a second. Let's delete this automation first by pressing the record button once. And then, to set an automation to be one-shot, keep pressed the record button for a second. The LED will start blinking 2 times in a row. Let's record an automation as before, but this time as a quick envelope. When we stop recording, you will see that the automation will not start the playback automatically. That's because it's waiting for a gate signal into the reset input, which, in this case, also doubles as a start or play input. To hear a simple example on how we can use this automation to be like an envelope, we can take the CV output and a gate signal from an off-screen arches, and let's see how we can play the T generator. Back to the square output, and we are going to automate both Morph and PWM parameters. For the PWM, let's emulate a random like LFO. And for the morph, let's create a slow attack, slow release envelope-like waveform. We can also set an already recorded automation to be in one-shot mode. Simply keep press the record button while the automation is playing. Now we will see that the LED is blinking 2 times fast. We can also undo this action by keeping the record button pressed again. If I now connect a button to the reset input and press it, we will see and hear that the automation started from the beginning. If we turn the sine oscillator volume back on, we will hear that the one-shot automation on the fold is still working. If we want it to not be affected by the reset input, which is global by default, we can simply keep pressed the lower button while we are the desired parameter. The 4 LEDs will blink, and now we can see from the relative LED that the parameter will now not be affected by the resets. The LEDs for the parameter excluded from the reset input will blink every second or so. Let's now listen to how external signals through the FM input affect the sounds of the oscillators, by taming the modulator oscillator with an attenuator, to control the resulting sounds. That was it, guys. Let's see you next time with other demos and videos on this channel. Bye!